The James Webb Space Telescope, JWST, has spotted things that are so astonishing, they may alter our understanding of life itself. But is Proxima B actually a different planet, or is it some kind of dangerous trap? The JWST, which is the most innovative tool we have, has been checking out Proxima B, a red planet that revolves around Proxima Centauri. Space enthusiasts and researchers of dwarf stars have been intrigued by it ever since its discovery. And now, the JWST is giving us a much better look. What we're seeing is pretty wild. We first learned about Proxima B back in 2013, but only now can the JWST actually demonstrate what's going on there. The telescope can take pictures using infrared light, allowing astronomers to see through the atmosphere and spot details we couldn't detect before. The findings are both exciting and a bit scary. Proxima B is just about halfway between its star, at 7.3 million kilometers away. That's less than 5% of the distance between Earth and the Sun. It takes only 11.2 Earth days to complete one orbit. The crazy thing is, Proxima Centauri isn't like our Sun. It's a red dwarf, which means it's unstable and frequently emits strong solar flares that disrupt the planets around it. And this is where things get even more bizarre. JWST got the clearest views of Proxima B ever. It turns out the planet is about 30% larger than Earth, so its gravity is stronger. But the truly bizarre thing is that Proxima B might be tidally locked with its star, meaning one side of the planet is always in daylight, and the other side is always in darkness. Imagine a world where the sun never sets on one side and never rises on the other. That's not a great situation for life. The side facing the star would be roasted by radiation, while the dark side would be a frozen desert. Could anything exist in those conditions? It seems unlikely, but you never know. However, the problems don't stop there. Proxima Centauri itself is a significant issue. The JWST shows that the star is much more active than we thought. It has strong magnetic fields that create powerful flares. In fact, Proxima B is hit by solar flares that carry a lot of energy. One flare in 2021 was 100 times stronger than anything we've ever seen from our Sun. That kind of energy could strip away the planet's atmosphere, leaving it exposed to space. Some scientists think that because the planet is extremely close to its star and constantly bombarded with solar flares, it's just not possible for life to exist there as we know it. But others argue that life might be able to adapt to such extreme conditions. Could there be organisms on Proxima B that have evolved to survive, or is the planet just a dead rock? As we continue studying Proxima B with the JWST, we're bound to find out more. One thing is certain, this little planet, only 4.2 light-years away, is far more complex and baffling than we ever imagined. Could Proxima B hold the key to understanding how life can exist in the universe? And if it does, what does that mean for our search for life beyond Earth? One of the most surprising things we learned about Proxima B is that it might not even have an atmosphere. The radiation from Proxima Centauri, combined with the planet's close orbit, means that Proxima B is constantly hit by solar wind and high-energy particles, possibly enough to have wiped out its atmosphere entirely. But here's the cool part. Some scientists think there may still be a thin atmosphere on Proxima B, maybe made of heavier gases like carbon dioxide or nitrogen. This could offer some protection from the harsh radiation. The James Webb Space Telescope has given us the best look yet at Proxima B's surface, and it's both intriguing and mysterious. The planet's surface seems rocky like Earth's, but with major differences. The side facing Proxima Centauri is probably blisteringly hot, like a desert, while the dark side could be frozen with temperatures much colder than anything on Earth. But the most interesting part may be the space between these extremes, the so-called twilight zone. That area might have milder temperatures where liquid water could exist. And liquid water is one of the most important ingredients for life as we know it. Could that twilight zone hide a narrow band where life has managed to survive? Another surprise came when scientists looked into the possibility of water on Proxima B. If it exists, it's probably ice on the dark side, or maybe small amounts of liquid water in the most temperate parts of the twilight zone. One possibility is underground oceans, like those on moons such as Europa or Enceladus in our own solar system. These oceans could be heated by the planet's core or polar regions. The planet's proximity to its star could even help warm these underground seas. If they exist, they could be promising places to look for life hidden below the surface. We also can't ignore Proxima Centauri's magnetic field. Recent research suggests that the star's magnetic activity might interact with the planet's core, possibly creating Proxima B's own magnetic field. This could help protect any atmosphere that remains, just as Earth's magnetic field protects us from the sun's harmful radiation. But it's complicated. The star's powerful flares could overwhelm the planet's magnetic defenses, causing sudden and dramatic changes in climate and surface conditions. Proxima B raises so many questions. Does it have a magnetic field? How strong is it? What effect does it have on the planet's atmosphere, and on the chances for life? Could life on Proxima B have evolved to survive those bizarre conditions? And if life does exist, what would it be like? Would it be something completely unfamiliar, or more like the tough microorganisms that survive in Earth's harshest environments? Even though the idea of a habitable planet around Proxima Centauri is exciting, the reality is that it may not be a very welcoming place. The James Webb Space Telescope has shown us the many challenges that any life, or future explorers, would face. One of the most serious issues is radiation. Proxima Centauri isn't like our Sun. It's a red dwarf star, which is smaller, more chaotic, and prone to sudden violent outbursts. Because Proxima B is so close, it's constantly being bombarded with extreme radiation, including ultraviolet and X-rays, that would be deadly to life as we know it. This isn't just theoretical. In April 2021, a flare from Proxima Centauri was strong enough to potentially wipe out any atmosphere Proxima B may have had. It's a powerful reminder that red dwarf stars, while common, can be dangerous. So, could Proxima B ever be a safe place for life? The JWST has spotted things that challenge what we think we know about habitability in the universe. Is Proxima B really a second Earth, or just a cosmic trap? With the JWST watching closely, we're finally getting answers, but they may not be the ones we were hoping for. Some scientists believe this constant bombardment could make Proxima B completely inhospitable. Without a thick atmosphere or some form of protection, the surface would be exposed to intense radiation that could sterilize it entirely. Yet, not all hope is lost. Some researchers argue that if life does exist on Proxima B, it would have to be radically different from anything on Earth, perhaps living underground, beneath layers of rock or ice that shield it from the harsh solar flares. Others believe that if the planet still retains even a thin atmosphere, it could contain trace amounts of gases like carbon dioxide or methane, which may be enough to support extremophile life forms, organisms that thrive in the most unthinkable environments. One of the most exciting ideas is the potential for a habitable twilight zone, the narrow region between the blistering day side and the freezing night side. In this zone, temperatures might be stable enough for liquid water to exist, and where water flows, life as we know it may follow. Imagine a ring around the planet, caught in eternal dusk, where alien organisms could live in relatively stable conditions, protected from the extremes of both heat and cold. Another intriguing possibility is subsurface oceans, hidden reservoirs of water kept warm by geothermal heat. Just like Jupiter's moon Europa or Saturn's Enceladus, Proxima B could have liquid water trapped under ice, possibly warmed by the heat from its core or from tidal forces caused by its close orbit. These underground oceans could be the best places to look for life, shielded from radiation and potentially rich in chemical nutrients. But again, Proxima B isn't an easy place to live. The flares from Proxima Centauri don't just damage the atmosphere, they also produce high levels of X-rays and ultraviolet radiation that would be lethal to surface life. These solar flares are so powerful that one of them, recorded in 2021, released more energy in seconds than our Sun does in an entire day. It's possible that Proxima B used to have a thicker atmosphere and even surface water, but over millions of years, the constant solar blasts could have stripped it bare. Still, there's a mystery here. If Proxima B has somehow held on to even part of its atmosphere, it suggests there's some protective mechanism at work. One theory is that the planet may have a strong magnetic field of its own, created by a molten iron core, much like Earth's. This magnetic field could act as a shield, deflecting solar radiation and helping preserve any remaining atmosphere. But no one knows for sure, yet. The James Webb Space Telescope is continuing to observe Proxima B and collect more data, trying to answer the big questions. Is there an atmosphere? Is there water? Could life exist there? Every new piece of information makes the mystery deeper and more complex. What seemed like a simple rocky planet just 4.2 light-years away has become a puzzle full of contradictions, dangerous, fascinating, and maybe, just maybe, not entirely lifeless. Whether Proxima B turns out to be a deadly wasteland or a hidden cradle of alien biology, it's forcing scientists to rethink what a habitable planet can look like. And as we keep exploring, one thing is becoming clear: the universe is far stranger, and more thrilling, than we ever imagined. Think that because it's so close to its star and gets hit by so many flares, life, as far as we are aware, probably cannot exist on Proxima B. But others think life might find a way. Maybe creatures on Proxima B have gotten used to the wild conditions. Or is the planet just a barren rock with no life at all? We're still looking. With the JWST looking at Proxima B, we can rest assured that we'll find more surprises, that much is certain. This little planet, only 4.2 light-years away, is far more complicated than we ever thought. Could Proxima B hold the key to comprehending how life can exist in the universe? And if so, what would that mean for finding alien life? We've learned some amazing things about Proxima B. One of the biggest surprises is that it may not even possess an atmosphere, or at least not much of one. Because it's so close to Proxima Centauri, the planet gets hammered by solar wind and high-energy particles all the time. This constant attack could have worn away its atmosphere, leaving it bare and cold. But here's the cool part. Some scientists think Proxima B might still have a thin atmosphere, possibly composed of heavier gaseous substances like carbon dioxide or nitrogen. This could give it some protection from the star's radiation. The best look yet has been provided by JWST. Proxima B's surface appears to be rocky, like Earth, but with some big differences. One side is probably locked facing Proxima Centauri. Because of the heat, it is likely a desert. The dark side, on the other hand, could be a frozen wasteland colder than anything on Earth. But what's most exciting is the strip in the middle of these two extremes, called the twilight zone. This is the area where day meets night. It might be warm enough for liquid water to exist. Since we know that liquid water is a crucial element for life to develop, this twilight zone could be a hidden place where life has managed to hang on despite the difficult circumstances everywhere else. Another cool thing is the possibility of water under the surface of Proxima B. If water is present, it's most likely on the dark side, in ice, or in small pools of liquid water in the twilight zone. But what's really got people talking is the idea of underground oceans, like the ones we found on moons like Enceladus and Europa in our own solar system. These oceans could be warmed by the core of the planet or by the pull of Proxima B's orbit around its star. If these oceans exist, they'd be great spots to look for life hiding below the surface. The James Webb Space Telescope continues its observations of this distant exoplanet. The mysteries of Proxima B keep unfolding. While the conditions on Proxima B seem harsh and unlikely to support life as we know it, they also push the boundaries of what we believe is feasible in terms of habitability. This planet, orbiting the red dwarf star Proxima Centauri, holds key insights into the broader search for life beyond our solar system. One major concern regarding Proxima B is its potential for having liquid water, which is essential for life. While most of the planet's surface has been scorched or frozen, the twilight zone between the two extremes may provide a more temperate environment. This narrow strip of land, where day meets night, may offer appropriate conditions for liquid water to exist, though it would face constant threats from radiation and the planet's extreme weather patterns. On the other hand, scientists are intrigued by the possibility of underground water reserves, possibly in the form of vast subterranean oceans beneath the planet's icy surface. Such an environment could create a stable haven for life, potentially even in microbial form, similar to what we see on Europa, one of Jupiter's moons. A fascinating aspect of Proxima B is the potential contribution its core might make to its capacity to support or safeguard life. Some experts speculate that Proxima B may have a magnetic field created by its core's activity, which could help shield the planet from the worst effects of solar radiation and solar winds. If true, this would be a game-changer in our understanding of what makes a planet habitable. Earth's own magnetic field, which protects us from solar winds and harmful radiation, is crucial to sustaining life here. So Proxima B's ability to generate a magnetic shield could increase its chances of supporting life. Despite this, the powerful magnetic fields of Proxima Centauri itself present an ongoing challenge. The star's unpredictable solar flares, significantly more powerful than those from our Sun, have the potential to strip away any atmosphere that Proxima B may have or severely damage it over time. One of the most worrying observations is that during solar flares, Proxima B could be bombarded with high amounts of ultraviolet light and X-rays, which would be deadly to most forms of life. Such conditions make the possibility of sustaining life over long periods seem slim, as any environment would be susceptible to being diminished by these massive bursts of energy. Moreover, the distinctive orbit of Proxima B adds another layer of complexity to its habitability. The planet's tidally locked rotation means that one side always faces the star, while the other lives in perpetual darkness. This results in high temperature gradients, with one side being baked by intense heat and the other a frigid wasteland. Life would need to come up with a way to survive in these polar extremes or find refuge in the narrow band of stability that separates them. But even here, the lack of shielding against solar flares would be a constant threat. Despite all this, the findings of the JWST continue to fuel hope that Proxima B could be more than just a barren, lifeless world. If life does exist there, it could be fundamentally different from everything we know, able to adapt and thrive under extreme conditions. Perhaps in the deep, ice-covered oceans, life has found a way to prevail over the odds. Or perhaps in the distant future, Proxima B will reveal more secrets that could change our understanding of life's adaptability across the universe. The next steps in exploring this fascinating world could give us access to some of the most innovative discoveries in astrobiology and planetary science. But we must not forget about the problems. Proxima Centauri's magnetic field makes things even harder. Recent studies suggest that the star's magnetic field may interfere with the planet's ability to generate its own magnetic field. Still, if Proxima B can maintain such a shield, it could protect the planet's atmosphere from being completely stripped away by solar wind, just like Earth's magnetic field protects us from the sun. Yet, things on Proxima B are complex. The star's strong flares could overpower the planet's defenses, leading to rapid and extreme changes to its surface and weather. This raises many questions. Does Proxima B possess a magnetic field? How strong is it? How does it affect the planet's atmosphere and potential for life? Could life on Proxima B have gotten used to the wild conditions of the planet? And if there is life, what would it look like? Would it be completely bizarre or novel? Might it be similar to the extremophiles that live in Earth's harshest environments? These extremophiles on Earth, organisms that thrive in boiling hydrothermal vents, acidic lakes, or the frozen depths of Antarctica, prove that life is resilient, adaptable, and full of surprises. If such life forms can evolve under Earth's most brutal conditions, perhaps Proxima B's own life, if it exists, would have evolved similar survival mechanisms: dense outer membranes, radiation-resistant cells, or perhaps even bioluminescence to navigate its eternally dark regions. The implications of finding such life are profound. It would mark the first time humanity has confirmed that life is not unique to Earth, expanding our understanding of biology and potentially rewriting evolutionary science. Moreover, if life can exist under the extreme conditions of Proxima B, it broadens the range of planets and moons we consider habitable. It also forces us to revisit the definition of a habitable zone. For decades, we defined it as the narrow range around a star where liquid water could exist on a planet's surface. But if subsurface oceans, geothermal heating, and atmospheric chemistry can sustain life beyond these boundaries, then the universe may be teeming with possibilities we once ignored. Proxima B is a test case, a cosmic laboratory for studying survival at the edge. The planet challenges our assumptions and inspires new technologies to better observe its surface, atmosphere, and potential biosignatures. Future missions may include next-generation telescopes with higher resolution, or even probes that could someday explore Proxima B directly. But for now, the James Webb Space Telescope continues its vigil, gathering faint but precious light from this distant neighbor. Each observation adds another piece to the puzzle. Is it a lifeless rock scarred by stellar violence? Or a hidden gem nurturing exotic forms of life beneath its surface? One day, we may have answers. Until then, Proxima B remains both a mystery and a mirror, reflecting our deepest hopes, fears, and questions about the cosmos and our place in it.